This video is on solving quadratic equations. To solve quadratic equations, we're going to use two different forms, which is factored form and standard form. So in order to solve quadratic equations, we can use what's called the zero product property that we use to find the roots. So we've already used them to find the roots to solve the equation. When we are solving for solutions, or when we're finding solutions to quadratic equations, we are actually just finding the x-intercepts. So we've already found the x-intercepts when we put them into factored form. We actually have used the zero product property when we found the x-intercepts. We just have to make it, instead of equal to y, we have to have the problem equal to 0. So you can only use the zero product property if an equation is set equal to 0. So it needs to be an equation. If it just says to factor, that's putting it into linear factors. But if it says to solve, you should have an equation in your problem. So let's look at this first example. We're going to solve by factoring by using the zero product property. We're going to factor the problem first. Then we will basically just find our x-intercepts, and we just will not write them as x-intercepts. We will keep it as x equals. So the first thing we need to do is to make sure that we have a quadratic equal to 0. Since it says solve, there should be an equals. There is, and we have a 0 here. That means that we can go ahead and start factoring. The first step is to always find your GCF. When it says factor, we're going to find our greatest common factor. The smallest number is a 1, so therefore our GCF so far is a 1. All three of these terms do not have x, so we cannot put an x in our greatest common factor. So our GCF is just 1. Since there are 3 terms, I'm going to use guess and check. I'll take my first term of x squared. I know that's x times x. And 30, which is 1 and 30, 2 and 15, 3 and 10, 5 and 6. And that's all of my factors of 30. Now I'm going to guess which problems or which numbers go together. So I'll put my 2 sets of parentheses. It's still equal to 0. I have to keep this equal to 0 throughout the entire problem. I know my GCF is 1, so there's a 1 on the outside. I know I can put my x and my x in the front because I know that x times x is equal to x squared. Then I'm going to use my 5 and 6 first, since those are the bottom numbers. I'll put my 5, and I'll put my 6. Now that's my guess, and I'm going to check them. So I multiply the insides, I get 5x. I multiply the outsides, I get 6x. 5 and 6 can give me an 11. I need it to be a negative 11, so if I do negative 5 minus 6, I do get negative 11. Then I check to make sure it gives me the positive 30. Negative 5 times negative 6 gives me a positive 30. That means that both of these should be negative. Therefore, I have my 2 factors. So I can erase my work to show my check. And I have it in factored form of x minus 5 times x minus 6 is equal to 0. I have factored it, but I'm not finished because it did say to solve. I use the zero product property so I can find my x-intercepts. I take my factors and I set them equal to 0. So I take my x minus 5 and I set it equal to 0. I take my x minus 6 and I set it equal to 0. I'm just solving, so my answer should be an x equals. When I solve for this one, I get x equals a positive 5. When I solve for this one, I get an x equals a positive 6. Those are my 2 solutions. Please remember that solutions, x-intercepts, roots, and zeros are all mean the same general thing. So I could write this as an x-intercept of 5, 0 and 6, 0 because those are the solutions to the quadratic. And we did this by factoring. Once we factored it, we still use the zero product property the same way we used when we found the x-intercepts. We just did not go that extra step and put it as a coordinate. On problem 2, it says to, again, solve by factoring. we need to see an equals, and it needs to be equal to 0. This is not equal to 0, so we need to get it equal to 0. We're going to take this negative 5x, we're going to add it to the other side. We do have to make sure that we put it into the correct spot. That should be your b value. So I'm going to keep my positive 2x squared as it is, but I need to move my negative 5x to the middle because that's the b. So I'm going to have that positive 5x, and I keep my c value of negative 3, and now it's equal to 0 because we've added the 5x to both sides, and we just put it into the correct spot. Now we can factor. So our first step is GCF. The smallest number is a 2, so I have 2, 5, and 3. 5 cannot be divided by 2, so I know my GCF is not 2. The next number would be a 1, because 1 times 2 gives me 2, so my GCF has to be a 1. All 3 of these do not have an x, so my GCF is just 1. So now I'll continue factoring. I'll take my first term of 2x squared. I know that is 1x times 2x. I'll take my 3, which I know is 1 times 3. And now I'm going to guess which goes where, and then we're going to check it. So I have 2 sets of parentheses, equals to 0. I keep that equal to 0 throughout. I put my 1x in the front and my 2x in the front. And then I guess to see which numbers go where. I'm going to start with the 1 here and my 3 here. Now I'm going to check to see if it works. So 1 times 2 is 2x, and 1 times 3 is going to be our 3x. Now 2 and 3, I need to give me 5, which will work if they're both positive. So I'm going to check. So 3 plus 2 is 5, but 3 times 2 is not 3. So I know that when I multiply this out, I will not get a negative 1, positive 1 and a positive 3. A positive 1 times a positive 3 does not give me a negative 3. That's what I'm checking for. So I would have to have a positive and a positive in here. The 5 would work, but the 3 would not. So I know that my guess is wrong. So I'm going to re-guess. So instead of using a positive 1 here and a positive 3, I'm going to switch them. I'm going to put my 3 here and my 1 here. So now I check. This gives me a 3 times 2 is a 6, and a 1 times 1 gives me a 1. I need to get a 5. 6 minus 1 does give me a 5, so that works. So now let's check the negative 3. I have a positive and a positive here, and then I have a positive and a negative here. So I have a 6 minus 1 gives me a positive 5, and a positive 3 times a negative 1 gives me a negative 3. So this is actually our factors. This one actually does work. So now I can erase the work from my check because I have the correct factors now. So I will rewrite this as parentheses x plus 3 and 2x minus 1 is equal to 0. Now we set up our factors equal to 0, so x plus 3 equals to 0, and 2x minus 1 equals to 0. So on this first one, I want to subtract 3, and we get x equals to negative 3. On this next one, I'm going to add 1, so I'm going to have 2x equals a positive 1, and then we have to divide by 2, so we get x is equal to a positive 1/2. So our two solutions are at x equals negative 3 and x equals positive 1/2. And we factor this using guess and check, and then we use a zero product property. So question 3, we have an equals here, but we do not have it equal to 0. So we need to get this equal to 0 by moving everything from the right-hand side. Let's move that to the left. So what we're going to do is we're going to subtract the 2a squared, and we're going to go ahead and add the 5 to the other side as well, and we're going to line them up. So we'll end up with a 3a squared minus 2a squared gives us a 1a squared. Then we have plus a. And then a negative 47 plus 5 gives us a negative 42 is equal to 0. Now that it's equal to 0, we can factor. Our GCF for this problem, our smallest number is 1, so our GCF has to be a 1. And then there's a squared, a, no a, so we cannot put an a. So we factor our first part of a squared, which gives us a times a. We factor our 42, which gives us 1 and 42, 2 and 21, 3 times 14, 4 doesn't work, 5 times something doesn't work, 6 times 7, and the next one would be 7, so these are all of our factors of 42. So now again we're going to guess, set it equal to 0. I'm going to put my a in the front, and then I'm going to guess, I'm going to put the 6 and the 7, and I'm going to check. So I have 6a and 7a. I need to get a 1, so I know 7 minus 6 would work. 7 minus 6 gives me a positive 1. So now I'm going to check my signs. So I have a positive and a negative have to give me a negative 6. So I'll make my 6 negative. And I need a positive, so I need a positive and a positive. So I know that 7 minus 6 gives me 1, and negative times a positive gives me the negative. So these are the correct factors. So now, since these are the correct factors, I can erase my check and write out that this is a minus 6 times a plus 7 is equal to 0. Now I can write out my zero product property of a minus 6 equals 0 and a plus 7 equals to 0. We can get the value of a equals to positive 6 and a equals to negative 7. Now the reason the zero product property works and what it really means is that if this entire value right here is 0, this would be 0 times everything, which would give us 0. The same thing holds true with if we were to make this factor equal to 0, then this entire thing is 0. 0 times all of that would be 0. That is why we use what's called the zero product property.